Alright, well, one, my G's, and welcome to question 13 of the mock exam. Now I can see here we have to use equation technique to determine the value of k, which there are infinitely many solutions. Now, we'll just turn the equations above into a matrices, so we'll just go ahead and do that now. So we've just done that now. And when it comes to infinitely many solutions on the equation technique, we have to cause the bottom row to be completely full of zeros, as you can see here. But we also want to have this zero here. So we have to do somewhat of an L shape for the zeros when we want to determine infinitely many solutions. So we'll go and do that now, and to do that, we'll have to use row 1, and to change row 2 and row 3. So row 1 will remain the same because it's not really relevant if there's any zeros or not. Now with row 2, we want that to equal row 2 minus 3 times row 1, as this will cause us to get the 0 that we need just here. And then obviously 3 times 2, 6, minus 2, minus 6, minus 8. Same with the 3's here, that will cause it to be minus 6, and then minus 7 here. And then with row 3 we're doing the same, except we're subtracting minus 2 times row 1 to get us the bottom zeros here. So they will all become 0, and this will become k minus 8 due to the 4 up here, timesing it by 2. Oh, whoop, I've done. Let's change this real quick. Minus 8 there. Alright, so that's that. Oh, and as you can see, I've already done it here. Obviously 0 equals k minus 8, therefore k equals 8, and therefore there are infinitely many solutions. So that's part A done there for you. And so we'll move on to part B. Now this one's very simple, it's just when k equals 3. So you simply do 0 equals, and then substitute the k for 3 minus 8, 0 equals minus 5. Now since 0 equals minus 5, that's actually not possible, obviously. So therefore the system has no solutions for this question. So that is part B done for you there. And then we're going to move on to part C. Alright, so we're now just up to part C of the question. And for this, we're going to use the original equations just up here. So we'll just go ahead and write these down. So we'll just do that here. So that's one there. I'll just do the second one below it. This is 3x minus 2y plus 3z equals 5. And I'll just do one here. 2x plus 4y plus 6z equals k. And now we know from up here, the original one, we know that k equals 8. So we're just going to erase that and let that equal 8. And what we're going to do for this question in particular is we're going to rearrange in terms of y. So we'll just go ahead and do that now. So this equals 4 minus x minus 3z over 2. This one here equals y 5 minus 3x minus 3z over negative 2. And this one here simply equals 8 minus 2x minus 6z over 4. Now, as you can see between these two ones here, they're actually the exact same line, because if we simplify this one here, it just becomes a 1 up there. And that means while they are technically the exact same line, they are parallel. So they're the two parallel lines. And then this one here is just an intersecting line. So when we graph that, we can find out that the system of equations can be geometrically interpreted as true parallel lines and one intersecting line, which of course, would look like that. So we'll just write that down. Let's get rid of this real quick. Yeah, so therefore what I said just then, system of equations is geometrically interpreted as true parallel lines. And one intersecting line. So yeah, as we've done, to figure that out, we just use the original equations and rearrange them for y, and just see what they'll look like when we graph them. And as you can see, two of them were the exact same, so they're parallel, and the third one was just an intersecting line that went off in the distance. So that's all for now.